So hi there, cool to Clem. This is another video from me, probably the last one for you for quite some while. This is not really about superhead receivers. This is just a circuit that I don't really want, but I give you, if you want to call it like that, because you like to build simple receivers. It's a so-called super regenerative receiver. As you can see, it has some familiarities with the 1 transistor FM transmitter circuits, but it has a coil here instead of the resistor. And the circuit is very simple. As you can see, it uses only 2 transistors. One is the main receiver transistor and the other one is just an audio amplifier. How does this circuit work? Well, it's basically a Colpitts oscillator by what you can tell, but there's something special. We have this coil here, and what happens is, if you adjust this bias right, which is very uncritical to adjust, it's way easier to adjust in a regenerative receiver. What happens is it starts to oscillate, but then there is this coil, which has for high frequencies a high resistance. And then the current builds up, and there is not enough current that it keeps oscillating, so it stops oscillating. Then it starts to oscillate again. Then the coil is filtering out the RF, which means that there is not enough current for it to keep oscillating, so it stops again, and it always starts, stops very fast. This is the so-called quench frequency. And the quench frequency is what you also get on the audio output, which is there. You get 2 frequencies. You get the audio signal from your received station, and at the same time you get the quench frequency, which could be like 25, 30 or 40 kilohertz or kilocycles. And what you have to do on the audio amp stage is you have to connect a capacitor from base to ground to filter out the quench frequency. What otherwise happens is that you get a signal out of the output, but it's very silent. So if you connect this capacitor from here to ground, then it filters out the quench frequency. This could be like, well, let's say I'm using a 47 nanofarads there, but you could use other values. So it's just experiment with it if you want. This capacitor can be aligned, like, for example, on the FM band it's 4.7 pico, and on shortwave I'm using 100 picofarads. This circuit is looking very complex, but this is just the super regenerative receiver with a 2-stage Class A audio amp with transistors. I was a little bit lazy on that. As I said, here is the bias, and the cool thing about this circuit is that it does have an HEC built in, so you don't need an HEC circuit. It's really sensitive for what it is. And yeah, it just works just fine. As you can see, I've written down nanofarads, kilo ohms, and because I know you want to build your own stuff, you want to build your own design. So I just give you an idea how you can build it. This one should be smaller than 100 picofarads, otherwise the circuit stops working. And these, of course, shouldn't be like 220 nanofarads. We are talking about 2 values, like 10, 15, something in that range. So not 200 nanofarads. I'm just giving you some values where you can work. This coil is very uncritical, but of course it should be around the frequency. For example, for the 49 meter band you could use 100 microhenry. For CB radio you could use 1.5 to 15 microhenry. So it's really not critical. I do have, I think I'm receiving around 9 or 10 megahertz now. And I am using 27 microhenry. I've also tried 100 microhenry, and it did work with both coils. Okay, I'll now turn on the radio and I'll attempt to hold the camera so that you can hear the speaker quite well. Turn on the radio, and what I'll do is, first I'll align the bias. So the potentiometer is now that it's on 0 volts. Now listen, meanwhile I turn the potentiometer. Here we go, it's working. You can hear the static. This sounds like a FM radio, if there's no signal being tuned in. Now I'll tune in a signal. The antenna I'm using is just a 50 centimeters long wire. It's not hooked up to a long antenna, just a 50 centimeters long wire. And as you can also see, I'm just using a loudspeaker and a battery and no ground wire connected, because there is no ground wire necessary for such a circuit. And now I'll tune in a radio station. Well, let's say that's the beauty of shortwave. But I think you get what I want to show you. It's a very sensitive and very easy to make receiver. Okay, Maybe if I come back later to that station, there's some talk going on and you can hear how voice is sounding on this receiver. So this is, as I said, a super regenerative receiver. I really recommend that you play around with circuits like that. Of course, you might add another follow audio amp, and if you add this typical class A stage, you'll know this one for sure. You also want to have another filter cap there. So I have two filter caps. On the beginning I have 22 nanofarads and then I have 47 nanofarads, but those are uncritical. Okay, what else to say for your superhead receiver? Thanks for replying to my videos. There's an idea which is around in the web, if you want to call it like that, for quite some while. So you could build like the front end of the receiver could be made as you did it. You build your input amplifier and your IF amp, but instead of using a diode for demodulation, you could use, for example, a regenerative receiver which is set to like 1 MHz. And then you can align the regenerative receiver fixed on 1 MHz, and then you can convert down all frequencies to 1 MHz and it will receive them. That gives you, depending on how you align it, a very sensitive and selective receiver. You save not only one coil, because you can use, if you are clever, you can use the first IF filter coil also as the coil for the regenerative receiver. You also get a sensitive receiver. But on the other hand, you will have issues with the HEC, because if you get a low signal, it will be silent. If you get a strong signal, it might even go into oscillation mode. So you may have to think about that. Other stuff, if you are interested in making videos that are people actually intended to watch, oh, I just, wait a minute. I'm just waiting for some speech going to be on the radio, so you can hear the speeches being received very clear. Anyway, so what you want, there are a few videos that are very popular. Homemade walkie-talkie videos are very popular, and DC to AC power inverters. I have a DC to AC power inverter video which has, I have watched a while ago and it had way more than 120,000 views. So if you want to build something, build a DC to AC power inverter. Make a project, make an explanation. I've seen your videos about the audio amp, class A audio amp, why not to connect the speaker between collector and plus and all the stuff, and it was an awesome explanation. And I'm sure you can do something like that about DC to AC power inverters once, if you want to go in the rather professional league, with a switch mode power supply and an H-bridge on the output, which makes the 50 Hz square wave. Or you can go for basic circuits like a AMV circuit with 50 cycles or 50 Hz and 2 MOSFETs and a transformer. I mean, you wind your transformers by yourself, and I'm sure you can get stuff to work there. Just a suggestion. And of course you can also build a walkie-talkie with such of these circuits. You can make a transistor amp. As you can see, this is a 4 transistor circuit and it's already quite loud. And you could make another 2 transistor or 1 transistor transmitter to it with a microphone. But you have to pay attention, because what these receivers can do, if you hold a crystal close to the antenna, like a quartz crystal, for example this one, which of course is the wrong frequency, but if you have one that is matched to the frequency your receiver is being tuned, somehow the receiver, even if you just hold it close to the antenna, starts to oscillate the crystal, and it of course then receives itself. So you have to be smart about that and think how you make it. Okay, these are just my suggestions. Clem, I just show you the circuit. Maybe it's interesting for you, because you can use BC548s. There are nothing special going on. It runs with 9 volt, as you could see from the video. And yeah, you might try this circuit. As I said, depending on which coil and tank circuit you use, you can get from shortwave even to the FM band. And I've even seen receivers for the UHF band. Of course, you have to pay attention to other details. Then you can't really build this one here as it is for UHF. You need other transistors and you need definitely other coils and quite some knowledge to get this running. But I've seen videos about these receivers running on UHF, and also in these cheap wireless thermometers. Often these super regenerative receivers are built in. Other point, once again, if you try to build a walkie-talkie circuit, because if you search for walkie-talkie DIY or something, there are quite a few videos, and the ones that are there are very popular. You can tell by tens of thousands of views. And of course, DC to AC power inverter is always a topic people are interested in. It's like a never-ending topic, if you want to call it like that, because you always need an inverter for a solar panel, car battery and stuff like that. And these are very popular. There you could make a tutorial how to make a simple DC to AC power inverter with a conventional transformer. And of course you need to regulate the voltage, that's one important thing. I've seen many circuits, but you need to control the voltage and regulate it, like with PWM or with a linear regulation. And of course you can go ahead and make a professional one, which is still rebuildable because of your super good tutorial, which is built on switch mode power supplies. Okay, one another try. Well, I attempted. But as you can see, there's just some obviously Chinese or something music going on, not much speech. So Clem, I really wish you much success with your Superhead project, but you can of course also check out this circuit. It's really reliable, it's really working, it's also pretty forgiving if you build it quite well. The only thing that is important is this 100 nanofarad cap here, which should be pretty close to ground and the top of this coil, because it's not only shorting the RF to ground, which is important in this circuit, it's also therefore enabling the oscillator to go into this into this receiver mode with the quench frequency. Okay, there's one disadvantage about these receivers. They are generating some RF interference. That means if you run this one and you're receiving a station and you hold a shortwave radio nearby, you will hear hissing and static noises on the radio, which is actually being broadcasted by this receiver. So it's a transmitter which is very fast turned on and turned off. But if you use this resistor down there, if you make in a very high value, and just using 10K for example, of course you can also put in a higher value, you're having a very weak transmitter since it's very widebanded and it doesn't really interfere with other electronics too much. Where do you find this transmitter? At this receiver stuff, you may know these very cheap 27 MHz child walkie-talkies. There you find pretty much such a receiver. It's a little bit more fancy if you want to call it like that, but it's basically this receiver. Oh, and by the way, for the license-free stuff, I think this is also allowed in the UK. There's a bandwidth on the 27 MHz range, which is CB radio basically, but there's a bandwidth overlaying with the CB radio frequencies. It's a variable, you can choose your own frequency. It's like from 26.8 to 27.2. I don't know exactly where this goes, you have to look it up. This is the so-called SRD range, short range device. And in theory, they are allowing you to make experiments with an effectively radiated power ERP of 10 milliwatts. So you can in theory build a 27 MHz transmitter with less than 10 milliwatts to be sure under this power level. And it would even be legal and you shouldn't be having trouble with the Ofcom. I think that's your government thingy there for radio stuff, the Ofcom. Here in Germany it's the BNetzA. And in America it's the FCC obviously. So if you want to experiment with that and have a good feeling about is it legal or isn't it, go on the 27 MHz range. You can also find some crystals there, or you can find, for example, a 13.56 MHz crystal, and then you can build an oscillator with a so-called high-pass filter that filters out the 27.12 MHz. Okay, yeah, that was my video for you, Clem. Once again, thanks for subscriptions, thanks for your replies, and yeah, best regards, Stefan.